Why is base64 needed? AKA why can't I just email a binary file? I was reading up on base64 encoding, and found this on Wikipedia. Base64 encoding schemes are commonly used when there is a need to encode binary data that needs to be stored and transferred over media that are designed to deal with textual data. And the example given is sending binary files via email. I'm trying to understand why base64 is needed. Since the binary data is a bunch of bytes, wouldn't it be directly translatable to ASCII, which is textual data? Why is base64 needed at all? Or does email have a problem with the control characters in ASCII?
There is a good Wikipedia article on this. The earliest iterations of NCP as used by ARPANET were more like bit streams than byte streams, or attempts to negotiate a convenient byte size. The 8-bit byte was only standardized on much later. There were also several attempts at creating file transfer protocols that would work in different machines. Mail was initially a function of the FTP protocol, primarily as the mail and MLFL commands, then split into MTP, later SMTP. Those machines often had differing character encodings, ASCII versus EBCDIC, or even different byte sizes, 8-bit bytes versus 6-bit versus. Therefore, mail transfer functions were initially defined for transferring relatively short messages in plain text, specifically, NVT ASCII. For example, RFC 772 says, "Mail representation and storage." Mail is transferred from a storage device in the sending host to a storage device in the receiving host. It may be necessary to perform certain transformations on the mail because data storage representations in the two systems are different. For example, NVT ASCII has different data storage representations in different systems. PDP-10s generally store NVT ASCII as 5 7-bit ASCII characters, left justified in a 36-bit word. 360s store NVT ASCII as 4 8-bit EBCDIC codes in a 32-bit word. Multics stores NVT ASCII as 4 9-bit characters in a 36-bit word. For the sake of simplicity, all data must be represented in MTP as NVT ASCII. This means that characters must be converted into the standard NVT ASCII representation when transmitting text, regardless of whether the sending and receiving hosts are dissimilar. The sender converts the data from its internal character representation to the standard 8-bit NVT ASCII representation, see the Telnet specification. The receiver converts the data from the standard form to its own internal form. In accordance with this standard, the sequence should be used to denote the end of a line of text. Even though 8 bits was being transmitted over the wire, the 8-bit would often get discarded or mangled, since there was no requirement to preserve it. In fact, some protocols required the 8-bit to be set to 0, such as the initial SMTP RFC as quoted below. In other words, the software was not 8-bit clean. Data transfer. The TCP connection supports the transmission of 8-bit bytes. The SMTP data is 7-bit ASCII characters. Each character is transmitted as an 8-bit byte with the high-order bit cleared to 0. This persisted for a long time even after 8-bit ISO 8859 hash character encodings became widespread. Even though some servers were already 8-bit clean, many others weren't, and blindly sending 8-bit data would have resulted in mangled messages. Later, extended SMTP was published, allowing mail servers to declare SMTP extensions they supported. One of them was 8-bit MIME, indicating that the receiving server could safely accept 8-bit data. MIME message parts can have content transfer encoding, 8-bit, indicating that they are not encoded in any way. However, the SMTP protocol remained line-based and has the 998 octet line limit, as well as using a line 0D0A2E0D0A as the end-of-message indicator. This means that even though most binary files could be sent unaltered, it is still possible that files containing this octet sequence would be interpreted as the end of transferred message, and the rest of the file as an SMTP command, possibly causing damage. Similarly, a line longer than 998 octets might be cut off by the receiving server. In 2000, the binary MIME ESMP extension was published as RFC 3030, allowing transfers of raw binary data over SMTP. The message is now transferred in chunks of pre-indicated length, with a zero-length chunk used as the terminator, and base64 and AMP. Similar encodings are not needed anymore. Unfortunately, few SMTP servers support this extension. For example, neither Postfix nor XM4 advertise chunking in reply to ELO. To take advantage of binary MIME, it would have to be supported by all servers in the message path, which can be more than just one or two. See also RFC 765, File Transfer Protocol, RFC 772, Mail Transfer Protocol, RFC 821, Simple Mail Transfer Protocol, Wikipedia, 8-bit clean, Wikipedia, 8-bit MIME.
Some older email systems and software were not 8-bit clean. The 8th bit was used as a control character. This was enough to muck up binary files, thus base64, or other encoding schemes, were needed.
If you want to support the channel, please consider subscribing.